Hey everyone, welcome back to the channel. Welcome to another video. Really excited to see everyone back here for another one, and especially as we continue learning all about tech. Now guys, in this video, we're gonna speak specifically on two frameworks that I have learned over the years, and these frameworks help you understand how internet devices communicate all over the world. And of course, those two frameworks are the OSI model and also as well the TCP IP model. Now there's two videos that I put out recently, and one talks about how the internet works, which is a phenomenal video that talks to you about how all these devices communicate. So make sure you check that one out because we're gonna build on those core lessons learned there. And the other video talks about core internet devices that help facilitate how we all communicate. So those are two videos to watch. If you have not seen them, go check those out first. And again, I'll put links in the description and possibly on the screen here as well. So once you watch those videos, come back to this one because again, we're going to build on those concepts. And again, guys, before we jump into things, make sure you go ahead and give me a like for the video as it helps the channel grow. Subscribe to the channel and turn on your notifications so that way you're notified when I upload new videos to the channel. And lastly, share this with a family member or friend. So with house pleasantries out of the way, let's go and jump to the desktop so that way we can learn all about the OSI model and also as well the TCP IP model. So welcome to my desktop, everyone. And of course, this is where we're gonna go over in details what the OSI model is, and also as well, we'll take a look at the TCP IP model as well. Now they're both two different frameworks. They pretty much are very, very similar in a sense, but we'll go through some examples so that way you guys can know what this looks like. As I mentioned originally, this builds on the core internet devices that we've already talked about. So when you think of router and switches and those kinds of devices, they utilize the OSI model or the TCP IP model in some shape or form. So if you haven't seen that video that I'm talking about the core internet devices, I'll go ahead and link it on the screen here, and I'll also link it in the description. And then there's another video that you should also check out too, and the other video talks about how the internet works. So if you haven't seen that video either as well, I'll go ahead and link it in the description and possibly as well on the screen here. So those are two videos to watch, and then you can come back to this one. Without further ado, let's jump into the OSI model and also as well the TCP IP model. So here we have our board here where I'm going to put a couple of things on the screen here. So first things first, let's go ahead and take a look at each of the models. So if I were to bring here, let's add this one on the screen. So here we are, we have our TCP IP model, and also as well to the left, we have our OSI model. So if we take a look at what these are, let's start with the TCP IP model first. So when we take a look at the TCP IP model on the right-hand side, the first thing on the top, you're gonna see what's called the application layer. And the application layer enables applications to access network services on your machine. So you'll typically see applications that use different protocols in order to communicate. So some examples of those protocols are HTTP, HTTPS, SSH, DNS. So as an example, if you've seen my videos in the past, which I showed you guys how to SSH from one machine to another, SSH happens at the application layer. Or in our particular case here, and we'll talk about this later on in the video, HTTP or HTTPS, those are protocols in order to request for a website to come to your computer. So for example, if I type in youtube.com, that uses HTTP, or if you want a secure connection, HTTPS, which most websites nowadays use a secure connection. So it is HTTPS. So I'm gonna go ahead and put in SSH, HTTP. You guys can make fun of my handwriting later. HTTPS. And we can do one more, which was DNS. So moving down the list here, let's talk about the transport section in the TCP IP model. And in the transport section, that's typically where you're gonna have protocols in order to connect to other machines. And that is where you'll find either TCP or UDP. So let's put in here TCP/UDP. Now real quick, TCP stands for Transmission Control Protocol, while UDP stands for User Datagram Protocol. Now I'm not gonna go into the specifics of how each one of these work, because that's gonna, of course, increase how long this video is, and I don't want you guys to be here forever. But in a nutshell, TCP provides a connection that allows you to make a handshake and say, hey, I'm gonna open up a connection Are you ready to receive what I'm about to send you? The other person then says, yes, I am, go ahead. And then you can start communicating back and forth. That is typically what you'll see in TCP, and an example of that can be, for example, a website. If I'm going to reach out to another server for a website, we'll do an example of this later on. But if I'm going to reach out to another server for a website, I want to establish a secure connection first, and then once I establish the connection, then go ahead and send me the information. Versus UDP, UDP is sort of, the best way that I can explain it is a best case delivery service. So meaning I'm gonna send you the data and I hope that you receive it. And if you don't, I mean, too bad there. Hopefully you do. Now we realize that a website is TCP because of course we want to make sure that the data gets back and forth. And that makes sense. But why would I want to use best case service, right? Where data could be lost and you don't know, but you're hoping that it gets there. And one of the best ways that I can put UDP is, let's say, for example, you are having a phone call over a Wi-Fi call. The problem with TCP is there's too much latency. You have a poor quality or a poor experience if you use the TCP protocol in order to establish that connection and send data back and forth. Again, too much latency. You're hoping that those data packets get sent and the voice gets put together on the other side to provide an excellent experience. And so UDP is used, so you send the data and you hope it gets there. And if it doesn't, sometimes you'll hear your voice breaking up in the call. That is an example of maybe packets that are being lost and you try to send them and you hope that it gets there. Another example besides the Wi-Fi calling where UDP makes a lot of sense is if you're gaming online. You don't have the time to sit there and wait for a connection to be established and hopefully that the data gets sent back and forth and there's acknowledgments that it has been. Because if you're, for example, playing Call of Duty on a map and you're looking to shoot somebody, that latency will kill your gaming experience because then maybe the player might jump around in the map and you are like, what the heck is going on? As opposed to UDP, UDP sends the data over quickly as possible and hopefully it gets there and it provides an awesome gaming experience. So that's a really quick and dirty example of the differences between TCP and UDP. And in later videos, we can go into details as to what exactly these are from a technical perspective. So next item on the list now in the TCP IP model is your internet section. And in the internet section, this is typically where you have IPv4 or IPv6. So this is where you attach an IP address, and this is where you create packets and you put in the IP address in order to be sent out over the wire. And speaking of wire, this is actually the last one on the TCP IP model. Now with the link layer, this is the area where typically you'll have a MAC address. And by the way, if you don't know what a MAC address is, go ahead and watch my previous videos that I talked about earlier because I do explain what a MAC address is in there. So you should know what that is by now if you've been watching the channel. So this is where the MAC address gets embedded and then it also gets sent over the wire. So this is where you'll either send it out over Ethernet or you will send it out over Wi-Fi. So essentially, this is what the TCP IP model stack looks like. And we'll go ahead and do an example of this so that way you can clearly see what is happening here. Now the OSI model offers a little bit more granularity so that way you can see that granularity compared to the TCP IP model. So if I were to compare the two, so the application in the TCP IP model is very similar to encompassing the application, the presentation, and the session layer for the OSI model. And by the way, I will break down what these three are in the next slide here, but I'm going to just show you how they compare in this particular model right here. So the transport layer in the TCP IP model is equal to the transport layer in the OSI model. Now the internet in the TCP IP stack is the same as the network in the OSI model, or very similar. And then finally, the link layer in the TCP IP model is encompassing the data link layer and the physical layer in the OSI model. So that's kind of how they compare. Now we understand a little bit as to what is happening on the TCP IP model with the application, the transport, and the internet, and of course the link layer. Let's tackle the OSI model a little bit more in details because I do want to explain the differences between the presentation layer, the session layer, and so on and so forth. So guys, here we have the OSI model, and I know I already went through the TCP IP model, and now we're taking a look at the OSI model. But instead of going through and talking about what is happening at each and every stage, I'd like to actually work through an example where we can leverage the OSI model to see what is happening. And then on top of that, we can go back to the TCP IP model and use that same example and apply it there as well, because after a while, you start to realize that sometimes when you talk about things and you don't actually see it, it's very difficult to understand. So let's do an example and work through that together so that way this all makes sense. So here we have a web browser, and if I were to go to youtube.com, and specifically I would go to my channel, and here is my channel, of course. What just happened in that whole entire process that basically took less than a second, not even a second actually, probably a couple of milliseconds to complete, but somehow you're on my page instantly. So let's take this example that we have here and apply it to the OSI model, so that way we know exactly what is happening at each and every layer. And then also as well, we can do the same thing in the TCP IP model, so that way you can see that as well. By the way, before we go through this example, you guys should be hitting that subscribe button, and also as well, hit the like button. So that way it helps the channel grow. All right, plug aside, let's jump into the example. So here we have a good example of our website on the right. So again, you're seeing my page, Acosta E.T.F on YouTube. So what happens when we go through this whole entire process? So in layer 7, this is where we put in our URL in our browser, and we can put this up over here to give us some more space, but it's www.youtube.com. Now this will bring you directly to YouTube, not necessarily on my channel, but if you want to go directly to my channel, there are some additional characters at the end of that URL that you see there that allow you to go to that specific page, which is my channel. But anyways, for simplicity's sake, let's just say we're going to youtube.com. So at the application layer, this is where a web browser will go ahead and open up a connection via HTTPS. Then the next thing that happened is the presentation layer. Now at the presentation layer, this is what translates data between the application and the network, and it handles encryption, compression, or data formats. So if we look at the example here, your browser and YouTube servers use what's called TLS encryption. Now that is encryption that is used to secure your HTTPS connection. We can put here on the presentation layer, secure HTTPS. And we do that using TLS. All right, so that is the next item on the list, is securing that HTTPS connection. So now we go on to the layer 5, which is the session layer. So in the session layer, this actually manages your session. Either you open it, you have it maintained, or you close a connection. So in this session here, this is how YouTube knows whether you're done watching a video and you want to leave and you close out your connection, or if you're still logged in and you're still interested in watching additional content. So we can call the session layer and we can say maintain connection. Now let's take a look at the transport layer. What is happening at the transport layer? Now at the transport layer, we actually talked about this very similarly to the TCP IP model. And this is where you'll have your protocols. And here we'll put a little arrow and we'll say TCP. So this is where you have a secure connection. And remember, I said that when you're using websites, typically they use a TCP connection. So they'll do a handshake and allow data to be sent back and forth, and we verify whether that data was sent correctly or not. And if it wasn't sent correctly, then the person who is receiving the data can actually request the sender to send that data again if they didn't receive it properly. So that all happens at the transport layer. So next up on the list now, and this is the network layer, this is where, I'll put another arrow here, this is where you have the IP level. So now when you have a piece of data that has to go out in the network somewhere, an IP address is included in your packets, and that is typically the IP address of your YouTube server. And that is where you are requesting data from. And then on top of that too, you're also putting your own IP address in that packet or in that information that you're sending out. And reason being is because YouTube needs to know exactly where to send the data back to. And fun fact, you can actually take a look at what the IP address is for YouTube. So here we have a command prompt, especially in Windows. So if I were to go ahead and do ping youtube.com, you can actually see we get a reply here. So this is actually YouTube's IP address here, 142.250.105.93. That is YouTube's IP address. And so whenever we are making a packet and we say, hey, we want to send data to YouTube servers, the computer automatically puts this IP address that you see right here, along with my IP address as well, in that information and sends it out over to YouTube. So that way YouTube knows, hey, who do we need to send that information back to? And also as well, when we send that information of what we're seeking for, all the other core devices out there in the internet know how to route this information. So moving on now, let's take a look at the data link layer. And in the data link layer, this one is very interesting because this is where frames move between devices on the same local network. Now you may be asking, why do we have frames and what is the purpose of that? So in the data link layer, and I've talked about this before in my other videos, this is where you'll typically have a MAC. Let's try spelling that again. This is where you have a MAC address. And if you've seen my videos before about what a MAC address is, you know basically it's the social security of every single internet device out there in the world. So when you are talking between devices on the same network, you don't need to go up the stack per se and go to an IP address because you're not routing outside of your network. All the data is staying within your network. So it's a lot faster. If you kind of take a look at this model here, it's a lot faster to go from 1 to 2 than it is to go from 1 to 2 to 3. Again, IP is for routing outside of your network. MAC addresses are for routing inside of your network. So at this layer, this is where a MAC address gets put into your packet. And then at that point, your computer moves that data to the router, and the router is able to see the MAC address and it says, oh, we have another device that has this MAC address that you're looking to send data to on our network, and they can route data in between each other. And again, this happens at the data link layer. And lastly, over here, this is your physical layer. So when we get to the physical layer, think about you're starting at 7 and working all the way down 6, 5, 4, 3, 2. And when you get to that data link, all that information now is encapsulated. Everything has been completed. Now we're ready to send over the network. And that is, of course, your physical layer. And this is where you'll have Ethernet and you'll have Wi-Fi. That's just two examples of physical. That means we're actually sending the data over the wire. So it can be Ethernet, it can be Wi-Fi, or for example, let's say it hits your cable modem, it could be DOCSIS. Let's say it's hitting a fiber modem. You can use fiber in this case. That is literally the ones and the zeros are being translated over some type of medium. And that is, of course, your physical layer. And that in a nutshell is the OSI model. Now here we are with the TCP IP model, and we're going to apply the same concepts that we did in the OSI model now, but of course for the TCP IP model, because I want you to see what is happening here. And again, it's not as granular as the OSI model, but similar is happening in the TCP IP model, and I want to go over that with you so that way you can see the differences. And so if we go down the list here, first one on the list is the application layer. So remember, we go from top to bottom. And what is happening here is at the application layer, you're sending that HTTP, or in our particular case, I'm going to go ahead and say HTTPS. And the reason for that is because most websites actually use HTTPS because they use secure connections. HTTP is what the unsecure connection is for, of course, sending information back and forth for getting websites. So when you go on your browser and you type in youtube.com in order to get to my page, as you're seeing here, a DNS query. Now, by the way, if you're interested in knowing what a DNS is Domain Name Service. And real quickly, in a nutshell, when you type in youtube.com, there was an IP address that was given. That is actually how computers communicate. So you need a service in order to say, hey, how do we take a name called youtube.com, and then you can tell me what that IP address is, and that, of course, is a DNS. So again, when you type in youtube.com, a DNS query resolves the domain to an IP address. And we saw that when I was able to ping youtube.com. The browser makes an HTTP request to load up the YouTube homepage. And then of course at the application layer, you'll also have the TLS encryption. So if we go back up to our OSI model, the TLS encryption happens at the presentation layer versus the TCP/IP model, it happens at the application layer. So it's interesting there. So next up on the transport list, you can see here that it breaks the request into TCP segments. So this is the layer that ensures reliable communications between the two devices, and you can either use TCP or UDP. But again, in websites are normally TCP. So TCP is used in order to deliver that website, of course, which is youtube.com. And this is where packet sequencing happens. So if you're interested in knowing what that is real quick, that is where you can put packets in order. So keep in mind that packets could come out of order. So if I send you data and I break it up into small pieces and I send you 1, 2, 3, but somehow 3 comes first, and then you get 1 and then you get 2, this is the area where you're putting all those packets together. This is also where error checking happens and also retransmitting the data if needed. So again, all of that happens at the transport layer. So we can say sequence error handling or just error and then retransmit. Now in the internet layer, this is where you start adding IP addresses for youtube.com. So keep in mind, in order for your computer to communicate, it has to be able to put your computer's IP. So let's say computer IP, and then it also has YouTube's IP. So again, when we think of the transport layer, and the transport layer is breaking up all of these communication packets and it's sequencing them and doing the error checking and all that stuff. So once it has everything packaged up, again, it has to send this information out somewhere. And so in order to send it out somewhere, you need the IP address of your computer, aka who the sender is, and where it's going to, aka the receiver. Or in our case, the sender is going to be my computer's IP address, and then the receiver is going to be YouTube's IP address. And then lastly, we go to the link layer. And in the link layer, this is where you add the MAC address of your computer, as you see there. So computer MAC. So this is my MAC address is being encapsulated. And then once it's encapsulated, we transmit those frames and we send it over the wire. So we'll say send over wire. So this is where the information now gets sent over either to your router that then goes to your cable modem, it goes to your fiber modem, whatever that looks like. But essentially you're sending it over some physical medium, which happens to be, again, it can be wireless, it can be Ethernet, it can be fiber, it can be cable. All different types of scenarios apply to different networks. And essentially, this is very similar to the OSI model, except not as granular. Now, the last thing that I'll let you guys know is whether it's TCP model or it's the OSI model, as we went down through each and every one of these scenarios. So as an example, if we were going to the internet and we were requesting all this stuff and we go down this stack, when this information hits the other computer, which is going to be YouTube in our case, it actually goes through the same exact process, but in reverse. So if we were to go back up to our OSI model, same thing happens, right? We go down the OSI model and we go ahead and send the information to youtube.com. And then when youtube.com receives it, we go up the OSI model and recreate everything again. Now you guys all know what is happening whenever we go to youtube.com and we go through that whole entire process. You've now walked through how to do it from an OSI perspective, and as well, you learned about the TCP IP model as well. So there you have it, guys. Now you know all about the TCP IP model and as well the OSI model. And I walked you through an example of how using youtube.com as an example, as you see right behind me here with my YouTube channel, how we can access youtube.com and how it goes through that OSI model, and also as well how it goes through that TCP IP model. Now there's a lot to learn today, guys, so if something didn't make sense, make sure you go ahead and replay the video and watch it again, because I'm telling you, practice does make perfect. It took me a little bit to figure this out, so if it didn't make sense, go ahead and rewatch the video, and in no time, you'll get it as well. So that'll do it for this video, guys. Hopefully you enjoyed the content. I love you all, I appreciate you guys, and before I head out, go ahead and give me a like for the video as it helps the channel grow. Subscribe to the channel and turn on your notifications so you're notified when I upload new videos to the channel. And of course, share this with a family member or a friend. And one last thing, guys, if you don't want to wait for my next video to come out, YouTube thinks you'll like this video popping up on screen. So go ahead and give that a watch, and I'll see everybody in the next one.